Alrighty. See, there's nothing to this but just to do it, you know? So that's what we're going to be doing today. Twitch.tv. I'm going to share this out on... Excuse me. I've just drank a lot of liquid. I need to burp. I've been in the sun all morning doing some wrestling and some fighting with friends on the waterfront. But let's write this. Going live on Twitch. Learning about building a full stack machine learning app plus learning about databases. It's all about the database because that's where come and say hi. Tweet. It's all about the database because, I mean, if you don't have a database... Oh, I didn't even... What a rookie. I didn't even link my Twitch. Waving hand. Come and say hi. And then... Oops. HTTPS. Twitch.tv/Mr. Dberg. Okay. Boom. And now let's delete this. Done. Get out of Twitter before we get distracted. And now let's move Twitch over to... Where did that go? Oh, here. There. There. We're nearly at 700 followers, team. Not that it really matters. I mean, I'm going to be live streaming this anyway because I like it and it's fun. But, no, I don't mean that you don't matter if you're following me. I mean that the number doesn't matter, people. Okay. There we go. Are you working on the thing you should be working on? I've got Queens of the Stone Age stuck in my head. Okay, this should be good enough. If you're joining, please let me know if you can hear me. Let's see if I can hear myself. Okay. And the other day, I had a bit of a blocked nose. I still kind of do, but I'm feeling much better. So where were we? Today we're going to do some fun things, as usual. September 15, Apple had their new event today. The new iPhone got announced. It uses machine learning to take some great cinematography videos. So we're still on building a data flywheel. What is a data flywheel? It's a place that you collect data, you model that data. If the model doesn't work as good as you want, you collect more data, you train a new model, and it goes on and on and on. So we're still building Nutrify. This is going to be what we're building for the foreseeable future. Today, Vedant, what's going on, my friend? Today, what we might as well do is start to clean up Notion, clean up the repo, because we're at sort of a little phase in the project where it's like, okay, we've got like the stage 1 down. Now, if we want to go to the next stage, well, we have to get that ready. So let's get that all ready. And I'm going to create a to-do page, to-do archive. All to-dos that have been completed. And now let's add a file. Boom. So can I just drag this in here? Done. Wonderful. Storage bucket. Make an archive of to-dos. Well, we can click that. So I've been looking into SQL, and it looks like Google Cloud Functions may be best to deploy our model for the time being. So today we're going to be doing some repo cleaning, code. We've got a couple of bugs in the code which we can fix today too. And then we can move this also into the archive. We're cleaning up the Notion. This is good. I should make this. We've done that. person location. Delete. Delete. We've done that. Yeah, we also want to start working on creating a database, because if I start to make YouTube videos about this and they start to, like, more and more people start to use the app, we want to have something that's not just Google Sheets for tracking all of the metadata. So GitHub, code, SQL, that'll be later on. And then cloud functions can be used for let's write in here, machine learning. So you'll notice that we haven't actually even done any machine learning yet. Why? Because we're getting the data set up. Once we've got the data set up, like, the machine learning will be plug and play. So machine learning, this can go under here. And then to do nutrition API. Ashik, what's going on? I'm glad you liked the new blog. Thank you very much. I liked it too. Okay, here's what we're going to do. We're going to take care of most of these today. And we're also going to learn about databases. I was watching a free code camp video the other day, or yesterday, sorry. Yeah, on Postgres Sql. So I think we're going to use Postgres. Today, learning about databases, cleaning up Notion, plus GitHub, and then fixing image bug in app. So let's get into code. And let's go to the GitHub. So by the way, Ashik is talking about this article. I wrote an article. It's my birthday the other day. Hello, Shivans. What's going on? Vedant, I've built a workstation for DL. Shivans, hello. So I use a Mac for day-to-day, but for machine learning, as we're going to get to that probably in a week or so, using the deep learning PC. I've got it set up now that I can SSH into it. So if we see here, I've been coding some PyTorch. So this is actually running on my deep learning PC. How about I just show you that now, actually? So if we go SSH, who wants to see some deep learning on a big dog GPU? SSH 192.168.142, no, 0.24. Wait, is the port broken? Clear. You know what? The power went out in my house, so I think my computer might not be on yet. Let me go turn it back on. So, my deep learning PC was off. That's why it didn't work. An electrician came to my house the other day and, yeah, did some electrical stuff. And now we're going to check, whatchamacallit, SSH 192.168.024. So that's the address of my computer downstairs. There we go, clear. So this is my deep learning PC downstairs. So if we got here, we've got code, we've got desktop, downloads, music, etc. Right? And so let's cd into code, ls, clear. So I've been reading a book on PyTorch, and then we're going to cd into PyTorch, ls, and we've got some notebooks here. So then if we just go into any random, to start a Jupyter notebook, we need another terminal, because I need to create, what Jupyter does is when you start a Jupyter server, Jupyter says, hey, run Jupyter on this port, which is, say like an internet channel, basically, if you imagine a TV. If I want Jupyter, I need to go SSH, which forwards a port on this machine to, I can type in here, Jupyter Notebook, no browser, and then we want port equals 8888, which is the default for Jupyter. Oh, I need to activate the environment. I should make a makefile to do all of this for me. So activate the env. I'll probably write a blog post about this because it took me a few goes to get this right. So now we can go Jupyter Notebook, no browser, and then port equals 8888. Wonderful, right? So now we've got Jupyter hosted there. But if we type this in, watch what happens. We type that in, it doesn't connect, right? And that's my blog post for the year, by the way, if you want to read that. Some cool ideas in there. So it doesn't connect, but now watch this. Because this is hosting the Jupyter Notebook on port 8888 on the deep learning PC, not on this computer. This computer is a Mac. So to fix that, we need to open a new terminal and we need to port SSH. So NL, I don't actually really know what NL stands for. I just know that you have to use that tag. You can look that up. But then I type in the port here. So it's like take this port on this local computer and forward it to localhost 8888 on Daniel at, so my username at 192.168.0.24. So this is, hey, this computer, forward this port to this port, the local host Daniel at this IP address, which is 88888 on my deep learning PC downstairs. Run that. Port forwarding, if we go back to Safari, remember that wasn't working before. And if we refresh, boom, we get a Jupyter server. Now, if we come in here, let's write a new notebook, Python 3, and then import torch. We've got PyTorch. And then if we go NVIDIA SMI, look at that. NVIDIA Titan RTX, 24 gigabytes of GPU memory, baby. And then if we go torch.tensor. So by default in PyTorch, the tensors aren't on the GPU. So let's x equals that. X, right? If we wanted to send it to the GPU, on PyTorch, you have to go device equals CUDA if torch.cuda is available. So CUDA is NVIDIA's GPU package that allows you to run machine learning, deep learning code on the GPU. CUDA if torch.cuda is available. So this is just CUDA.is available is going to tell us if we've got, I'm going to do more PyTorch streams in the future, don't worry. True, else CPU, right? So now we'll print device is CUDA because I have a GPU available. So now if we go x.to device, and then we go, see what that says. That's going to send that tensor to the device. There we go, beautiful. Now that tensor was originally when we created it on CPU. Now the tensor is on the GPU. TensorFlow does this automatically behind the scenes, but that has some advantages, has some disadvantages, whatever. We'll get into that in another point, but that's my deep learning PC. We're going to use that in a future stream to build a lot of models. For now, we're not working on that. But let me know if you'd like to see more streams on that. Okay, we want to look into, let's go to the GitHub and get the issues up. yeah, no one can SSH into my computer because I have the keys. So even though you have that IP address, it's only IP address on the local host, so my local internet connection, and I've set up the whatchamacallit, the private keys between the two computers, so they communicate using keys. PyTorch Lightning looks very cool as well. So Shabir says that there's an issue on an Android phone that they can't access their camera with our app. I think, Siobhan's, you're right. Facts aren't visible when device is in dark mode due to color of background text. I'll fix this today. Working on. Now I feel like the not being able to use camera issue may be Android device specific, e.g. works on some but not others. Adding functionality for the image to be removed when uploading is done now. Okay, let's comment that and let's code that. Is this still running? Refresh. Let's do a little testy test. Stake. I actually don't like the autofill here, so maybe we'll get rid of that as the default. So this is stake test eggs test au test and upload. So what they're saying is Shabir says that yeah, the image stays around. Is that what we want? Let's delete that image, eh? We'll see what we can do to get rid of that image. Can you see me if I code over here? Maybe I code on this side. Put the app on the other side. Okay, so when that we surely can just put some code here that after the image has been uploaded, remove I might put ST success right down the bottom too, because that's let's put that here. And then we can also remove the image. Or set uploaded image to none. Let's see what happens. Yeah, if someone makes a typo, I haven't thought about, you're right, I haven't thought about that far ahead. However, what I think I will be doing in the future is building using natural language models on here. So even if someone types like pizza, like I could use a natural language processing model here that figures out what is it close enough to pizza. Does that make sense? So I think that's just to go forward. Or we could have I'm only doing it for English to start with, but different languages, sure. But here we could do like an autofill as well eventually. So this is just a prototype, right? So eventually, like say you start typing like bacon. All right, it's once you start to type bacon, it's going to start to autofill bacon for you. But we'll get to that later on. Uploaded image equals none. Let's see what happens when that happens. So if I click this, oh. We can always add more complexity later on. So Nutrify, like stage 1 is just getting this to work for 10 food images. That's what we're going to be doing like probably next week. As soon as I get the database up and running, we'll build a machine learning model to make this app work. We'll find a nutrition API and we'll get it to work for 10 different types of food classes. And then we can just upscale it from there. Like once we have the infrastructure and data, like the data engine in like working for a small sample, then we can just start to add more compute, add more resources, etc., etc. So what's in here? Pizza, AU, and my email. Okay, I think we should put a kill switch in here. So what do we reckon, team? Do we get rid of that image after it's been uploaded? I think so. Let's go to Streamlit API. Remove. I need to log into the forum so I can upvote things. Obviously, just want to log in with GitHub, don't I? uploaded image.empty. No, image.empty. Okay, I think this will work now. Empty. Hey, Paran, what's going on? I'm trying to output the details. And I think my keyboard is about to die. So let's get rid of the image. I think that's a little bit too large as well. This is pizza. Okay. What? Oh, yeah, because it's got if it's not none. Local variable. Oh, I need to make it. There we go. Samantha, what's going on, my friend? We're fixing a little tidbit of the app that it doesn't. Look, there it's gone. We need to remove the uploaded file, don't we? So we got the displayed image and the pizza file there. Then we type in pizza, AU, upload. So it's going to save to the Google storage bucket. Uploaded file has no attribute, empty. Streamlit, remove. Hey. Hey, Streamlit. They're a professor or teacher using Streamlit in any way. I could get Streamlit to sponsor the streams. Day Adam, what's happening? So let's now go into, I want to state. There we go. Oh, I don't think state works for uploaded files. Okay. Now, what's the error we're getting? Uploaded file. Yeah, we could get a sponsor for the stream. Streamlit. Streamlit sponsoring the stream. Streamlit, delete. Be sure to change the key number with a clear button. Okay. Clear file. Where's this button coming from? This is cool. This is built with Streamlit. I need an audio file. What is Hugging Faces Spaces? Let me get an audio file. Then I want to trim this. Hugging Face Spaces. Oh, what's diet nerf? Chef Transformer. Wonder if I can delete. Python. That's what we should be doing. We should be removing. So let's uploaded file. Let's have a look at the docs for that. And then this is saying I have to so it says upload a file with the key. Okay, I think I can do this with a session state variable. Let's see what we can do. Upload key. Not in Nikom, how are you? Good morning from, or good afternoon from Australia. st.sessionstate. Now we want key. Okay, and now print. Okay, so we're just basically changing the key. Wonder if this will work. If in doubt, test it out. So what we're trying to do is remove the uploaded file. Okay, let's say pizza, email, upload. Uploaded image, changing upload file key from 0 to 1. But see how the file's still there? Then if I click upload image, okay, that's all right actually. If I try to upload image, okay, I see. Then I can have, all right, so the key is now only one unless we change it. I got an idea. We'll use UUID. And then this will remove it every single time. So this will be a random key every single time we upload a file. Watch. So every time we upload a file, it gets a random key. And then every time we finish it, to remove it from the app, it gets given another key, but then we upload another file, and every time, just every single time, it generates a new key. There we go. Upload key there. So we got the pizza image there, okay? There's the original key. Pizza. Click upload. And so in order to have this image removed, the way Streamlit works is it saves this image under some sort of key. So now uploaded image, changing file, upload key from that. That was the original key up here to this. That way, if we click the image now, upload image, please upload an image. Okay, so now let's upload another image, hamburger. Wonderful. Now, every single time we come down here, we should get another key. So there's our current key, 8C3FF. And write hamburger, 8C3FF for the key, upload. So then boom, changing the key from that to this. So now that hamburger image is no longer there. If we try to upload the image, it'll say, please upload an image. So we have a new key, browse file, let's go hamburger. We have a new key. Now we'll copy the first bit of this. There, hamburger, fries. There's the key, upload image, and then we reset the image key to this. Wonderful. So now we try to click upload image again. Please upload an image. Wonderful. Okay, there we go. We've now got something that clears our store image upload ID as key. This will be changed once image is uploaded. Beautiful. We've got a way to remove images now. To do this, the key, it's stored under Streamlets uploaded file gets changed to something random. A hacky clear. There we go. Now, what issue was that? Oh, I was checking out Label Studio yesterday too. So I have an issue. This was number 16. Fix image not being What didn't pass here? Shivans, this is what messes me up. Black didn't pass the check. What's this say? Files were modified by this hook. There we go. I think it might have just formatted my comments or something. Okay, beautiful. So that should be on the repo now. We just fixed that. Okay, one more issue fix, and then we're going to get onto something of clearing up the GitHub. So if we look at this, so this is the deployed app now. It does look sexy though. Look at that. Our app is only 200 lines and it's got some great functionality. So yeah, I'm not going to upload anything to the production. But you see this text here? It's dark when it's on dark mode. So let's turn on dark mode.
Okay, I turned on dark mode.
See? If we can't really read that. So let's just add a background to this. Turn off dark mode.
Okay, I turned off dark mode.
And then we just need to refresh this. Well, this is stuck in dark mode. Okay, let's go to whimsical. We can do this with export, include background, check. Okay, that's a bit better. And then we want downloads. With background, and then I'm going to move this into code, Nutrify images. There we go. Okay. Let's go to the local version. Uploading. Oh, oops. There we go. Okay, that looks better. Now let's fix the file name. Okay, now this should work. Turn on dark mode.
Okay, I turned on dark mode.
There we go. And if we look at the deployed version of the app, there we go. Okay, I like that. So, turn off dark mode.
Okay, I turned off dark mode.
Okay, I'm not sure why it's not working for... Yeah, there should be documentation for setting up the project. Now, let's just add some info to the GitHub. Repo will be folder with misc images. Okay, I think that's pretty good. Yeah, I'm shilling for Streamlit right here. Streamlit is an amazing app, and if they would like to sponsor future streams or future YouTube videos, I would be all ears for that. Using Streamlit. Using Streamlit Cloud. It does this. And then we want here, and we want an image. Images. No, I just need that file name, don't I? Does that need to be in? Okay, beautiful. You're right, I could edit this in the repo, in the local. But if we just commit here, then we can just go git pull, and we get the changes. And I should clean up the Notion so that people can track the progress. I'll do that later on. So clean up repo, that's done. 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 Delete. Okay, first stage. Yes. Let's write this. Where's the readme? Readme. Master plan. Note. This is very likely. As of, what's the date? 15th September. Stage 1. Build food image collection app. Need a way to store images at large scale. Images object storage info about images. That can be relational database. Postgres, object storage is Google Storage. Build small prototype computer vision app to take a photo of stage 3. Merge. Stage 4. Upgrade. World's 100 most commonly eaten foods. Stage 5. Repeat the above until almost every food you can eat is covered. Okay. So that's what we'll do. We've built the food image collection app, small prototype, nutrition information. This will be done via API and via a public nutrition API. If you know of one, please let me know. More images get taken, models get improved, more images, better models, more images, better models, etc. Start with top of the Pareto. Okay, I like this. Now, where's the view, the README? Open preview. Beautiful. Okay, we're up to here. Currently here. Git commit, add master plan. Okay, the repo is good enough for now, for sure. What other projects do we have in progress? We want to put, yeah, we should work on malicious content. We'll work on that in a second. I want to get a database together. Start working on having robust database option, e.g. prototype, it's Google Sheets, but could we It's all about the database, people. Then eventually people will be able to start creating accounts and whatever and yada, 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 and save your foods and learn about them. That's the web app. The web app is going to be, that's what we're talking about when we talk about the stages. You know what? I did see with malicious content, we can get out of all this. Let's just write down what we've done. Image persistence bug in app. Done. Wrote out master plan. Likely to change over time, but that'll be the first major milestones. Random ideas for all images, yes. Well, we've already done that. I think we can get rid of this. You know what I saw on, speaking of malicious content, I saw a way with image magic that blurs out that malicious content. So what we could do is get out of that. Holy but Jesus, man. Let's get out of that. So the modeling, we'll do a lot more modeling code later on, but we're just getting it all set up at the moment. Close. 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 And we can minimize. I've been reading up on Made with ML as well, by the way. I'd really recommend this resource for just basically everything to do with ML ops, which is getting machine learning models into production. So the other day I read up on pre-commit, thanks to Siobhan. Siobhan actually added that functionality to Nutrify, which is styling. And then we have a whole bunch of stuff here that I was looking into testing. We're going to have to do this later. Basically, we're going to be working through this entire curriculum, but in the ML Ops repo, Goku Mohandas uses an app to demo this, but we're just using our own app. Get rid of that. Yeah, there we go. Oh, and I added a source for where the image came from as well. So that way we'll know where the image got uploaded from. So when we start to move it into the actual detection app, we can use that later on. And then we were back to malicious content. So Google Vision API, malicious content. How to check an image for malicious content. Python. let's go back to made with ML. So pre-commit, Goku does some great checks in here. Keys. But that's what the git ignore does. Yeah, here we go. Trim trailing white space, check YAML, check for added large files, check Python AST, check JSON, detect AWS credentials, detect private key. That's important. Now, pre-commit YAML. Is there AWS here? Oh. There we go. This is what we could do. Pre-commit. What hooks are there? So hooks are, when I make a commit, hooks, this is going to check, this is by Shivans, thank you, by the way, Shivans, thank you very much for uploading this. Hooks will check that if you're committing something that you shouldn't be committing to GitHub. So say I write some code, right, and I put in there some information about how to access my Google Cloud account, and I don't want that to be on GitHub because that's going to be accessible publicly. Well, then you put in pre-commit hooks that checks your files and goes, hey, you've uploaded a secret credential here. You might not want to save that to GitHub, which is accessible publicly. So that is where the value of pre-commit hooks come in. So I'll be back in a sec. I'm going to read up some more of what we could do. Mostly just with like private keys and AWS. No, sorry, GCP. I'm using GCP. I'll be back. So a little more pre-commit hooks, and then we're going to learn some more about databases. We got GCP here. Google. Key. I wonder if we can put detect private key in there. So we come in here to our pre-commit. So there's some private keys there. JSON keys. ID detect private key. Marcus, what's going on? Linux or Windows better for coding? Personally, I only ever use Mac or Linux. I don't have a Windows machine. So the computer I have downstairs is running Linux. The computers I use on all of cloud, so like Google Cloud, AWS, are all running Linux. And this is running Mac OS. So I would prefer Linux, but if you're buying like a laptop, it's probably going to come with Windows. So that's more than fine. You can access Linux from Windows as well. So yeah, whatever you need to get the job done. Detect private key, and what else did Goku use here? JSON. What does JSON do? Now I'm going to just update the pre-commit. No, add private key. Beautiful. So that's just to check. I don't know. I actually really don't know what that does, but I'm just going to put it there because detect private key, why not? But as always, you should definitely not upload your keys to GitHub. This is what the git ignore does, by the way. The git ignore file tells Python, or tells Git, like what files to save to Git and what files to not. And you can generate a pre-formatted git ignore from, so see here, don't save any JSON files, don't save anything in my secrets file, don't save dsstore, which appears on Mac all the time. You can auto-generate git ignore, auto-create git ignore on TopTool. So I just typed in Python, and then it creates a git ignore. So that way, when I upload all this stuff to GitHub and share it with you guys, I got a little tickle in my throat. You have access to the files that you should have access to, but you don't have access to the files you shouldn't have access to. So, by the way, here's the app. Oh, that didn't work. Okay, now let's go back to learning about databases. So this is what I was watching the other day, Learn Postgres Sql tutorial for beginners. Let's see what we can do here. I need to get a drink of water. I'll be back. Okay. Oh, that'll be a cool feature.
you can see that I have a few files in here, but the one that I'm interested is this one here. So .zshrc. So I'm going to do I and then .zshrc, just like that. So now I need to add the export right here. So I'm going to press I and then simply say export and then path equals to and then $sign and then path / and if I go back to open Postgres and then open it again, so you see that I'm after this path right here. So I'm going to grab all of that.
Okay, so this is Postgres. Let's open this. So what I'm doing now, I'm setting up a database, and that's what Postgres is. So SQL is a query language, so it allows you to, say we have Google Sheets, right? This is where our data is currently. And we want to query this line. We wanted to get, oh my goodness. See, this is why we need to get out of Google Sheets, because it's too easily to edit and whatnot. So we wanted to get all the files from here with the word hamburger in it. Well, we could go select file or row with label contains hamburger, something like that, right? And then we get all those image codes, and then we can download them from our Google storage bucket, which is on Google Cloud. So this is what we eventually want to get to, is having a proper database set up. So that's what I'm watching this video for. It's Free Code Camp's Postgres SQL tutorial. SQL is the language you use to write that command. Postgres is the engine that runs the database. So I'm up to this step. Postgres. Oh, and by the way, this is the Postgres app for Mac. So a lot of pieces of the puzzle that we have to connect here, but basically all computers you can or applications you can boil down to is have data somewhere, store it somewhere, then have an application that just picks data from that application, from that database, and displays it to someone. So every time you log into Facebook, all that's doing is going, hey, Facebook database, it's me, Daniel, I'm logging into your website, pull everything, all my information from your big database and show it to me. So that's what we need to create. We need to create somewhere to store a lot of information. So let's go to here. I need to alter my path.
And then this should be colon and / and then paste that. And then go back and then copy this here. It should be colon and / and then paste that. And we don't need the actual PSQL. So this I need to add.
So this guy just started editing. It's basically just saying where your database is to your terminal. So I want Vim. I'm in tilde, which is home. See this tilde symbol? CD tilde. If I change to desktop, it's going to have desktop. And now we need to CD. Vim ZHHRC. Okay, Conda.
Like that. So now I need to add the export right here. So I'm going to
What's end of line in Vim? $. I for insert, down, comment. Now we're going to put in, might get this one over here.
and then simply say export, and then path equals to, and then dollar sign, and then path forward slash, and if I go back.
Is there already a path variable in here? No. Path.
Press, and then go back again.
So now I have this. Let's get out of these extra terminal windows. Postgres here. I want to copy that. Need start of line in Vim. Zero. There we go. Now I've already seen this part. WQ to save.
You see that after this path over here, so I'm going to all of that, Command C, and then go back, and then this should be.
That's why I had my drink over here.
And then paste that in. And we don't need the actual PSQL. So just let me add a space right there, then use that, and then to escape out of that, simply press escape, and then colon WQ. There we go. So now if I say source, so to pick up the changes I made.
Source is going to refresh.
There we go. So if I now clear screen, Command L, and then simply type PSQL, you see that we have PSQL working without having to specify the full path. Alright, so previously you installed Postgres.
Hold on. Command not found. I just updated. Yeah, there we go. The path's already set there. What do the comments say here?
Escape out of that, simply press escape, and then colon WQ.
Let's figure out what's going on here.
There we go. So now if I say source, so to pick up the changes.
We need to change this.
ZSHRC. There we go. So if I now clear the screen, Command L.
Conda is already using the path.
Well, you see that we have PSQL working without having to specify the full path.
Okay. Ah, I see. I forgot the path. There we go. Okay, we've got PSQL here.
Press escape and then colon WQ. There we go. So now if I say source, so to pick up the changes I made in ZSHRC.
Learning SQL team. Postgres Sql.
Working without having to specify the full path. so because I'm going to be using PSQL as well. Alright, so in the previous video, we managed to add PSQL to the path. So now we can simply type PSQL, and there we go. So just let me quit out of this, and basically,
Oh, to quit, you write Q.
mode right here, where you see that using PSQL, the version is 11, and if you need help, you can type help. So help, and there we go. So you see that we get some help. Now, basically, every single command right here starts with a backslash. So if I want to quit out of this mode, I can simply type backslash and then Q, and then as you can see, I'm no longer in the actual PSQL mode. So let me go ahead and start PSQL again, and if I clear out of that, and then if I simply type backslash and then question mark, you see that I get more help. And basically, there is a bunch of things that we're going to cover in this course.
Hey.
So let me go ahead and press Q, and if I press help again, if I press backslash and then L, and then press enter, you see that this command simply lists all of the databases that we have in our. You see that press help, we're going to cover in this course. So let me go ahead and press Q, and if I press help again, if I press backslash and then L, and then press enter, you see that this command simply lists all of the databases that we have in our computer. So right here you see that I've got 4 databases: Amigos Code, Postgres, 10.0, and then 12.1. So by default, these are generated for us.
Okay, Daniel, Postgres, template. So this is a list of databases that we have. End. How do I get out of this? Escape.
Postgres, 10.0, or computer. So right here you see that I've got 4 databases: Amigos Code, Postgres, 10.0, and then 10.1. So by default, these are generated for us, but we can create our own database. To do so, we need to use a command that creates a fresh database that we can then create all the tables inside of this database. And to do so, we need to use the command create and then database, and then we have to give it a name. So this database must have a name. So the name can be anything you want, but what comes before it, meaning create database, must be exactly like that. So you can either use lowercase or uppercase, so you can say create and then database. I personally prefer the database way because that way I know what is SQL syntax and what is not. So I'm going to use uppercase, so create and then database.
So SQL syntax is uppercase.
And then make sure to end that with a semicolon, because otherwise it won't execute the command. So I'm going to press enter, and you see that you have this looking flag which says create database. Now to view the list of all databases,
End with a semicolon.
backslash and then L. Enter, and right here you can see that this is the database that we just created. Alright, so in this video I'm going to show you how to connect to databases. And there are 2 ways. First one is...
Hey, there's our first database. Look at that. Food vision test. How to clear PSQL, and then if we want to clear hey, there we go, clear.
PSQL, and please follow along because this is the way that you will learn. So PSQL and then dash dash and then help. So right here you see that we get a bunch of help. So these are the usages. So you can see that PSQL and then options, and then the actual name followed by the username. So right here you see that for database name, simply type dash D, and if I scroll down, so you can see that these are the names.
So this is help.
So the host is minus or actually dash H or dash dash host equals to host name. The same for port is dash B, and then dash capital U for username or dash dash username, minus W or actually dash W, and then dash capital W for no password. So let's give it a go. So PSQL and then dash and then H, and then the host will be the local host. But if you were connected to a remote server, then you would type the actual IP address, and then dash and then U for the actual username. So amigos and then code. And by default, you can see that the actual username is unable scope. So before actually giving the username, I'm going to say dash and then p, and this is the actual port. So by default, our database is running on 45432, and that's default by Postgres. And then we can specify the actual database name. So our database was called test, and if I press enter, you can see that we are connected into the test database. If I was to quit out of that and then write the same command, but let's say that we want to connect to a database that doesn't exist, so test1, enter, you see that we get this PSQL fatal error saying that the database test1 does not exist. The same for, let's say, the actual user. So Windows code, sleep, multiple S's. Enter.
Hey, there we go. We're connected to our database.
Same for the actual ports. Fine. Add one there, enter, you see that the connection was refused. So let's go ahead and connect the test. There we go. So now we are inside of the test database. So this is one way to connect to this database called test. The other way is if I press backslash and then Q to exit, and then clear this clean, I can type PSQL, and then I can do backslash and then L. So this lists the databases. And by the way, if you missed where I got this backslash L, command is from PSQL-help. And at the very top, you'll see that you can list the available databases. So I'm going to press Q, and PSQL, clear the screen, and then backslash L. So now you see that I do have this database called test. Now the way that we can connect from here is simply by saying backslash and then C for connect, and then I can type test. Enter. You can see that now we are connected to the database.
C for connect. Food Vision test.
Different database. So let's say that we want to connect to this
Beautiful.
Amigos code. Simply type C and then Amigos. Press tab, and that order completes for you, and then enter, and there we go. So you can switch between databases just like so. So Postgres, enter, and there we go. So we're going to go ahead and connect to test because this is the database that we're going to be using. And there we go. And
hey.
Alright, in this video I want to share with you a very, very important command that you should be aware of, and you should take extra careful when using it. So in the previous video I showed you how to create this database called test, and let's say that for some reason you want to get rid of this database called test, i.e. delete. So to create a database you simply say create and then database, and then you give it a name, in our case test. To delete a database you simply say drop and then database, and then the actual name. So, and also make sure to end at the semicolon. I'm not just going to run it yet because I want to stress out why this is very dangerous. So it's dangerous because let's say that you have this database called test with 5 or 10 years worth of history. So that could be, if you have a business, that could be, for example, customer information, addresses, emails, the transactions that they made, login credentials, so on and so forth. So if you were to run this command on that database, this means that all of its content is lost in a matter of milliseconds. Really, it's just that quick. So when you have, for example, a production application and you log in or SSH into your box, you should never run this command because you will lose pretty much every single data in it. And often if you SSH or log in into a remote database, then you should have access or some kind of monitoring to see what people are allowed to do. And because I'm teaching you Postgres, it's absolutely fine for us to experiment with this command. After all, we don't have any important data in that database, right? So let me go ahead and press enter, and you can see that the database.
There we create a test.
Seconds. Let me go ahead and press backslash and then L, and you can see that the database is gone. So no data in it. So often as well, if you have one database, you have to make sure that you have a backup of your data in case of any eventual accidentally loss of information. So let's go ahead and recreate this database because we're going to need to this course. So create a database and then test. And make sure to end up with a semicolon, otherwise the command won't execute. So I'm going to press enter, and I go ahead and press Ctrl L, and then backslash and then L, you can see that we have our database back again. So the point of this video was really to stress out how dangerous it is to execute any kind of drop command. Alright, in this video I'm going to show you how to create your very first table with Postgres. So to create a table you need to write a command. table, so this is pure SQL, and then you define the actual table name, and then inside of parentheses, you can have as many columns as you want. So the columns have few attributes. So the very first one that you must have is column name, and then the second one that you also must have is the data type. So the data type for that column name.
Let's bring up Notion.
And then if you have any constraints, you should also specify them. So I'm going to explain what this means in a second. But for now, let's say that you want to represent people in your database. So you have a table like this. So you have a table called person. So you write create table person, and then inside you see that I define the actual columns that this table called person has. So the first one is ID, and the data type of it is int, so integer, meaning that it's numbers. And then I have first name, which is varchar. So varchar is pretty much just characters, and then 50 means that the maximum length that this column called first name can have is 50 characters long. The same for last name. Then I also have a column called gender, and this as well is varchar, so characters up to length 6, and then I have date of birth, and the data type is timestamp. Maybe we don't actually need a timestamp because timestamp includes the full date, including hour, minutes, and seconds. So maybe we can use a date instead of timestamp, but I'm going to show you that in a second. So this is it. So let me show you a list of all data types that you might encounter with Postgres. This is the documentation for data types within Postgres. I'm going to leave a link in the description below so you can access this page. But if I scroll down, you can see that you have a bunch of information, so table of contents. So just let me scroll down because it will be easier for you to see right here. So you can see that the data types that you have can be big int, so this is a signed 8 byte number. Big serial, booleans for true or false. You have characters, you have
I want to also look up Firebase Firestore. That's really for user accounts.
Bar chart. So this is the alias that I was using, and then you have date. So this is the one that we should actually use for date of birth. So as you can see, it only contains year, month, and then the actual day. And you have double, you have JSON, you have money. So this is when dealing with money. So any currency amount. You have numeric. So for betting. So this is the actual alias. So
We actually don't need to store too many things to begin with. The first thing will be to replicate the database we have right now, this, in Postgres. So that'll be fun. We'll figure out how to do that in Python.
you need to have serial. So serial is a 4-byte integer, but this is special because it auto increments automatically for you. So I'm going to show you how to use that in a second as well. And then you have text. So when you have text, there is no max length. And then you have, this is just time, and then timestamp. So right here, you can see that the timestamp contains the actual date plus hour, minutes, and seconds, plus the actual milliseconds. And you also have UID, which is a good one for IDs, and then you can also have XML data. So go ahead and navigate to this page to familiarize yourself with all of these data types. Let's go ahead and connect to our database called test and create our very first table. So I'm going to go ahead and press /C for connect. And then test, and then enter, and see that I'm now connected to database test as user Amigos code. So let me go ahead and clear the screen, so Control L. And to create our very first table, we need to write this command that I've showed you previously. So just let me open the docs, or actually the slides, so that you remember exactly what I have mentioned in the previous video. So create table, the name, and then the actual columns. So in uppercase for SQL commands, create and then table, and then the actual name was person, and remember this was singular, and then open parentheses. And now if I press enter, this command will be executed until I end up with a semicolon. So now let's go ahead and have our very first column called ID, and this was int, so uppercase int. And then we also had the first name, and this was varchar, and then 50. We've also had last name, and this was varchar 52. We also had gender, and this was varchar, I think it was 6 or 7, but let's go ahead with 7. And then let's go ahead and finally have the actual date of birth, so date of and then birth. And we say that instead of timestamp, right, because we don't really know, the time of when someone gives birth, we don't usually store that information. So let's go ahead and have the data type as date, and I'm going to end up with a parenthesis. So open parenthesis, close parenthesis, and then end up with a semicolon. So if I now execute this command, so press enter, you see that we have a table. Now the way that we see the list of all the tables that we have in our database, it's simply by pressing backslash and then D. So D for describe. So if I press backslash D, you can see that we have one table called person, and you can see the type is table. Now we can even go one step further.
Hey, there we go.
Describe the actual table name, so person. If I press enter, and now you can see that we have one table called person.
See?
Columns are ID.
Okay, there's what we need for... We've already starting to get close to what we've got in Google Sheets. So we can still use Google Sheets. We'll probably use both to begin with, actually. Make a copy of them.
The first name, last name.
Because that's what I...
Birth,
Yeah.
you can see the type, so the data type.
It's fun learning new things.
Right here, and there is some extra information. So nullable, so these are the constraints, and you can also have 3 4 values when you create a record in this table. And this is how you create a table using Postgres. So in the previous video, we created the above table without any constraints whatsoever. So basically, what we can do is specify some extra constraint into our table creation to enforce that before someone inserts a new record into this table, it must satisfy these constraints. Because currently, in our table called person, we can go ahead and pretty much just create a person without an ID, without first name, without last name, without gender, and also without date of birth. So what is the point of having a person without any of this information? So to improve on that, what we can do is simply specify the actual constraint. So on the table below, you can see that the ID becomes now big zero. So this is an improvement because big zeros do increment by themselves. And then I'm saying that this column must not be null, so not null. And I'm also specifying that the ID is the primary key for this table. So the ID is what uniquely identifies a person in the actual table. So the same for first name. So what I'm saying is not null. So if you want to insert a person into this table, you should specify the first name, last name, gender, as well as date of birth. Let's go ahead and improve our table with these ones.
So the primary key, I'm assuming, is the index.
So what I'm going to do is go back to item or command line if you want on Windows. And remember, a few videos ago, I showed you how to drop a database. We can also drop tables. Again, you have to be very careful when you perform this operation, but because I'm showing you how to improve this table, we can pretty much drop it and we don't have any data in it as well. So go ahead and simply say drop and then table, and then the table name is called person. Enter. If I now do backslash and then D, you see that did not find any relations. So let's go ahead and improve on the actual table creation. So let me just clear everything. And let's go ahead and say create, and then table, and then person, parentheses, and then inside, let's go ahead and ID. This will be big and then serial. So big serial means that it's a signed integer which auto increments. So big serial, and then this will be not null. So we must have one of these, and then primary key. So all of this is SQL syntax. Let's go ahead and do pretty much the same for first name, char, and then this will be 50. Actually, I do have a mistake, so I forgot to add much. All of this is SQL column, and this should break out. So actually, not column, so end that like that. And let's go ahead and duplicate this. There we go. So now we want to do now. Enter. be not null. So you might be saying, okay, Nelson, so everything is not null. When should a column be nullable? So when a new person is added to this table, they may or may not have an email, right? Not everybody has an email. So we can go ahead and add another column called email. And this will be, let's go ahead and say var and then char. And this will be something a bit bigger. So let's go ahead and say 150 characters. And if I say not null, so this is not true because some people don't have an email. So I'm going to leave this column as nullable. So now I'm going to end that with parentheses and also end that with semicolon. If I now press enter, we can see that we have our table. If I control L to clear the screen and then /B, we see that we have this person right here, but we also have this person ID sequence. And the reason why we have this sequence is because of the big serial that we created. So big serial, as I mentioned, is an auto increment number. So we don't have to keep on remembering the previous number. So if I go to the docs, and then you can see that right here, if I can find it. So right here, auto increment 8-byte integer. So this person ID sequence is not a table, you can see right here. It's simply a sequence. So we can go ahead and simply say /, or actually backslash, and then D, and then person, and then enter. And now look at this. So our table is much better because we have these constraints right here. So
Hey.
the first name, last name, gender, and date of birth. And also the actual email, so this email right here, is because not everybody has an email, so it is nullable. In this video, let's go ahead and learn how to insert records into tables. So far, we have a database called test with one table called person with the following columns: ID, first name, last name, gender, date of birth, and email. So let's say that we want to insert a new person into this table. So the person will have the ID of 1, name Anne, last name Smith, gender female, and the following date of birth, the 9th of January of 1980, and this person does not have an email. So to create this person into our table, we have to write the following command: insert into, and then the actual table name, and then we have to specify the columns that we want to insert. In this case, person, last name, gender, and date of birth. So remember, this person...
So insert into person, first name, last name, gender, date of birth. Insert into person. It's right here. So the values are in the same order as the columns. That could be an error.
Therefore, we don't have to specify the email column. And then we have to say values. And then values takes an array of values matching the column's data types. So in our case, Anne Smith, female, and then the last column, date of birth, is actually date and not a string. So the way that you represent dates is by simply saying date, and then you have to make sure...
Oh, you have to type date.
And the month, and then the actual date. So there we go. So this is how you insert new records into any table. So let's now say that we want to insert a second record into this table, i.e. a second person. So let's go ahead and simply say insert into person. So insert into the actual table name called person. And then the column that we will insert to our first name, last name, gender, date of birth. And in this case, this person has an email. So we also specify the actual email. And then we simply pass all the values. So Jake Jones, male, and then date of birth is 19th, the month is January, and then the day is the 10th. And once we execute that command, we will get a new person with an ID of 2 into our database. So as you see, I'm not specifying the actual ID column, and this is because if you remember correctly, the big serial data type does an auto increment for us, which means that we don't have to manage this ID. So if we insert more people into this table, we simply get the ID managed for us, i.e. being auto incremented. So you'll get 1, 2, 3.
The date automatically goes up. The ID.
Alright, so now I'm inside of PSQL, and I'm going to press \d, so lowercase d, and you can see the list of relations. So this is just to refresh your mind. So we have person and then person ID. This is the sequence for our ID. If you want to see just the tables, press \d and then t. So this shows just tables. And you can see we only have one table. So let's go ahead and insert a person into this table. So the command is insert and then into and then the actual table name, so person, and then we have to specify the actual columns. So I'm not going to specify the ID because that's managed by us by this sequence right here, so person ID sequence. So I'm going to specify first name, last name, gender, and then date of birth. So let's say that this person does not have an email, right? And that with parentheses, and then I press enter. This command will be executed until you end the entire command with semicolon if you don't remember. And then I will say values, and inside parentheses, the values, so it takes an array of values, and they have to match the same order as the column's names specified right here. So the first name is Anne, and then the last name is Smith, so she's a female, so female, and then the date of birth is date, and then within quotes 1988, and then 01 for February, and then the 9th. So remember that first comes the year, month, and then the actual day. And then if I end up with semicolon and then enter, you see that we get this message right here, insert 01. So that means that the insert did work. Let's go ahead and pretty much just do the same command, but this time let's go ahead and add an email. So this will be email. So I'll just press the up arrow and I got the same command. So in case you're wondering. So this is Jones and then Jones. So this is actually Jake Jones. And if I go back this way.
Oh, data of birth column. Derp. Oh, does it have to be single ticks? Anyone know about SQL? Do you need single ticks? Okay, there we go. We've got an insert, our first insert.
Email. So email.
Then we might as well put in a comma here. Email. No, this can be john@gmail.com. And we want to go all the way back up to here for email. And then we want John White, male, and 1993. Oh, I wonder what's going on here now.
I go all the way down here. Let's say that this guy is from 1990, and then let's say the 12th, and then let's say the 31st. And I also have to specify the email. So let's say that email is jake@gmail.com. If I press enter, you can see that this same command did work. And this is how you insert into tables. So far we have two people in our table, and so right here, and also Jake. In this video, let's go ahead and add
Hey, there's our table. Look at that team. First name, last name, gender, date of birth, email. We've got something looking similar to what we're going to need for Food Vision. We'll have image ID, upload time, which will be a timestamp, image height, width, label, country, email.
1,000 more people in our table, and also add a column called country of birth. So in order for us to add 1,000 more people into our table, we're going to use this website called Mockaroo. So this is simply a data generator. Basically, we can generate data in various formats. So right here you can see that we can select our fields and basically
Mockaroo, we can generate mock data using Mockaroo to test different entries into databases. What do we got? 439. Mockaroo. Ahee. Beautiful. This is probably what we'll be able to do for mock. So we'll create a mock database and then just pull from that database. I like that.
you can then select the types and have some options. So for our table person, we going to exclude the actual ID because this is managed by the sequence for us. So we have first name, last name, and then gender, and we don't actually have the IP address. And let's go ahead and add the date and then of and then birth. And this will be date. So if we select the type and simply search for date, and right here we can actually specify the format. So year, month, and day. And let's also configure the actual email. So let's say that 30% of them will be null. So we want to have some people in our table with nullable email addresses. And 70% of them will actually have an email. And finally,
And what date should we have it as?
country.
Oh, 30% are going to have blank.
Or better. And instead of date, let's go ahead and pick the country. So there we go, country. And I think this is good for now. So now you can see that we can generate 1,000 rows. And basically, if you want more than 1,000, you can keep on downloading 1,000 each time, or you can actually sign up and then you can generate more than 1,000 rows. So 1,000 for us is fine for this course. And the format, go ahead and change that to SQL. But you can see that they have XML, 5.8, Cassandra, JSON, and so on and so forth. So go ahead and pick.
Hey, this is very cool. Then we want SQL.
Pick SQL. And then the actual table name, so let's actually change this to person. And what we're going to do is actually include the create table. Now go ahead and preview. And you can see that data contains a bunch of random people, some with email, and others without email. And if you click on the SQL, you can see that we have a bunch of inserts. And right here we have the actual create table. So you've learned this in the previous videos. So
Hey.
go ahead and go to that and simply download the data. Download. There we go. So now we have this person.sql. And to open this file, I'm going to be using VS Code. So VS Code for me is the best IDE out there for working with SQL files and pretty much like with web development as well. So this is the one to go. But if I'm doing like more backend server side work, then I'm using Tetra. So you can use VS Code or Atom. So Atom is actually good as well. Atom. Or you can use Sublime. So go ahead and pick your favorite IDE. But for this course, I'm going to be using VS Code. So I'm going to open that file with VS Code. So I'm going to open VS Code and then File and then Open. And then inside of Download, this is my person.sql. And there we go. So now you can see that we have the create table. So you've learned about this. And also you learned how to insert into tables. So insert into person, first name, last name, email, gender, date of birth, and also our new column called country.
Let's open this with VS Code. Hey, there we go. Now we can do this for dummy foods, you know. This is very good. Very, very good. Once we know what sort of foods we can use for Nutrify, we can generate dummy data and then use that to build our front end.
And then you can see all the values. So there is one change that we have to do, and that is to make these fields nulls. So I'm going to select those columns right there, and then I'm going to say not or null, apart from the actual email. Remember the email is null. And also let's go ahead and increase the actual size of the email. So let's say 100, or actually 150, and then the gender should be actually 7. And country of birth, I think 50 should be fine. So I'm going to save this. Now we can actually grab everything, so copy and paste into our terminal, and then execute all of these statements. But what we're going to do is something much more clever than that. So go back to your terminal or command line, and basically if you press backslash and then question mark, you can see that if I go right down, so you can see right here in the input and output section, we have this command right here, backslash I, and then you specify the actual file. So this executes commands from a file. Now I'm going to come out of that and then open up a new shell, and if I make this bigger, so what you need to do is to actually navigate to your downloads or whatever you save the file. So I'm going to navigate to documents, or actually it was downloads, so downloads, there you go. And now if I do an LA, you can see that we have person.sql right here. And to get the actual path, I simply have to type DWE, and you can see that the path is users and Libras code and downloads. So I'm going to grab all of that, so command C, go back to my main shell, and now we can go ahead and execute that file. So let's go ahead and press backslash and then I, and paste the actual file destination, / and then person.sql. If I now press enter, you see that we get errors, and the error is that the country of birth of relation use destination / and then person.
Oh, errors. Country of birth doesn't exist.
If I now press enter, you see that we get errors. And the error is that the country of birth of relation person does not exist. And that's correct. So if I clear the screen and then do a backslash and then D and then person, you can see that we don't have the country of birth qualifier here. So let's go ahead and drop this table. That's right, drop. And as I've mentioned before, using the drop command is not ideal, but because I'm just teaching you how to use new commands, and this is just for illustration purposes, it's absolutely fine. But if you have a production database, do not run this command. Version per deal. That's right.
Okay. I've got jiu-jitsu in about an hour, so I'm going to go for a walk. And now I'm up to here. Copy this. I'm going to write this down. Let's go into building a data flywheel. And today's stream was pretty good. We cleaned up Notion, we cleaned up GitHub, we fixed a bunch of code errors, and now I'm up to here. Start looking database, looking into SQL, up to creating and adding rows to a database. So that's, I might finish the rest of this video off stream, so that way I can come back and just use it with knowledge. I'm not entirely sure how this is going to fit in. I basically think that a good idea would be to replace this database with an SQL one. So we say we wanted to use Python with Postgres Sql. Yeah, scicog p. Yeah, scicog g2. Connect, execute. Yeah, so this is what we'll want to be doing. Connecting to the database, updating the database, queries. Okay, it's not too hard. Create, read, update, delete. So this is all we'll have to be doing. It's just adding rows to a database of different images that they have been stored somewhere. And then who knows where we can host this database, but we'll figure that out. So the app should be a lot cleaner in progress. Yes, we're in progress. That's what we're doing. Okay, so next time we're going to keep going, or I'll probably finish this video before next time. That's probably a good idea. But next time we're going to make the database a bit better. And then we're going to look into get a Streamlit app working for 10 classes of food images. So then we can start to piece together the puzzle. So a prototype version of this. So once we've got a database to store images, we'll have a single database of probably just all the images ever passing through each app. That'll save the database. That'll be the primary database. And then we'll just index off the IDs of those images to where they've been used. And then we'll figure out how to do the rest from there. But I'm going for a walk to enjoy the afternoon. Thank you for joining into the stream. If you want all the code, it is on GitHub under Mr. Dberg/Nutrify. So I'll just put it in here. We didn't add too much to the GitHub today. Today was more of a learning stream. But anyway, the journey to building Nutrify, take a photo of food and learn about it, is well and truly on the way. I'll see you next time.